Good morning everyone. Now I am going to explain about the phases of compiler. Before going to know the phases of the compiler, we should know what is mean by compiler. So here compiler is a program that can read the program in one language, so that is the source language, and translate that source language into another language known as target language. An important role of the compiler is to report any errors in the source program that is detects during the translation process. Next we will see what is the structure of the compiler. So here compiler consisting of two parts. First one is the analysis part and second one is the synthesis part. Here analysis part breaks up the source program into pieces and imposes a grammatical structure on them. So it then uses this structure to create a intermediate representation of the source program. So if the analysis part detects that source program is syntactically or semantically weak, then the rules of grammar compiler provides information messages to the user in the format of errors, so that the user can take corrective actions. So this analysis part collects the information about source program and stores in a symbol table, which is passed along with the intermediate code to synthesis part. So next one is the synthesis part. Synthesis part constructs a desired target program from intermediate code and information in the symbol table. The analysis part is also called as the front end of the compiler, and the synthesis part is called as the back end. Next we will see the phases of the compiler. So here in compilation process operates as a sequence of phases, each of which transforms one representation to another. A decomposition of compiler into phases is shown as in this figure. So here several phases may be grouped together. The symbol table, so here we having the symbol table and error handler. So these two phases connects to each and every phases of the compiler here. So here the symbol table which stores the information about the entire source program is used by all phases of the compiler. Some compilers have optimization phase between the front end and the back end. The purpose of code optimization is to do some transformations in intermediate code so that the back end can produce a better target program. So here the phases of the compiler is, first one is lexical analyzer, second one syntax analyzer, third one semantic analyzer, and next one is the intermediate code generator, next code optimizer, and last one is the code generator. So here we will see one by one. So first one is the lexical analysis. The first phase of the compiler is called as the lexical analyzer, or it is also called as scanner. The lexical analyzer reads the stream of characters in a source program and groups them into a meaningful sequences called as lexemes. So for each lexeme, the lexical analyzer produces output a token of the form. So here a token of the form can be represented as token name comma attribute value. So these two can be represented in angular brackets. So this lexical analyzer is passed to the next phase of the syntax analysis. In token, first component, token name is a symbol that is used during a syntax analysis. Attribute value points to an entry in the symbol table. For this token information in symbol table is needed for semantic analysis and code generation. So here we will see one example, new value equal to old value plus 12. So here tokens are new value identifier and equal to. So this is the assignment operator. Plus is an add operator, and here 12 is a number. So symbol table can stores information about all the keywords, numbers, variables, and some special characters. All information should be available in the symbol table only. Next phase of the compiler is syntax analyzer. So the second phase compiler syntax analyzer is also called as the parser. So this parser uses first component of a token produced by the lexical analyzer to create a tree like intermediate representation. So that can give the grammatical structure of token stream. This tree structure is known as syntax tree. So here the tree shows the order in which assignment is performed. For example, in this statement, position equal to initial plus rate into sum 12. In this parse tree, the root equal to denotes the right child result should be stored in the identifier position. So next we will see next phase of the compiler is semantic analyzer. So here semantic analyzer uses the syntax tree and the information in symbol table to check the source program for semantic consistently with the language definition. An important part of semantic analysis is type checking, compiler checking. That compiler checks each operator has matching operands. The language specification may permit type conversion known as the conversion. For example, in binary arithmetic operator may be applied to either on two integers or on two floating point numbers. If operator is applied to floating point number and integer, the compiler will convert integer into a floating point number. Such conversion appears in the following syntax tree. We consider the position and rate have been declared to floating point numbers, and 12 is an integer. The type checker is in semantic analysis converts 12 to float number. Next phase of the compiler is intermediate code generation. While converting source program into machine code, a compiler may convert to one or more intermediate forms. Syntax tree are a form of intermediate representations which are used in syntax and semantic phases. After syntax and semantic analysis, compiler will generate an explicit low level or machine like intermediate representation. It will have two important properties. Those are, it should be easy to produce, and second one is it should be easy to translate into the target machine code. Here we will see one format of intermediate code used is 3 address code, which consisting of assembly like instructions with 3 operands per instruction. Each operand act like a register. In 3 address code generation, it will follow some rules. First one is the at most one operator should be present at right side of an instruction. Second rule is to store the result, temporary names are used at left side. And third one is some instructions may have fewer than 3 operands. And next phase of the code optimizer. So in code optimization, machine independent code optimization phase attempts to improve intermediate code so that better target code will result. Better means faster, shorter, and which consumes less power. In above intermediate code representation, the optimizer can reduce the conversion of 12 from into to float by replacing 12 by 12.0. Next, the final phase of the compiler is code generation. So in code generator was intermediate representation of source program and maps it into the target language. If target language code is machine code, registers or memory locations are selected for each variable used in the program. An important task of code generation is assignment of register to hold variables. For example, in previous optimized intermediate code, using registers R1 translated to machine code as follows. So here we having some instructions. Those are move id to R1 multiplication, multiply id 3 R1, add hash 1. So this is the correct value. So that's why hash 1 R1 move R1 comma id1. So in this, the first operand in which in each instruction specifies a destination. So here, if in each instruction tells as about, it deals with the floating point numbers. So this is about phases of the compiler design. All the 6 phases we have to remember.